So remember that near record warmth from before? Now it's like a distant memory, as there is actually somewhat intense rain falling. As the storms that produce the tornadoes are now getting on our doorstep. And our temperatures have chilled down to 59 degrees, and it feels a lot colder thanks to this incoming rain. Earlier, it actually felt like a warm rain that you normally experience in late spring or summer. Highly anomalous for February. But now it is starting to get more of those February rain-like character. It's starting to get more of its act together, and it definitely is coming down now at more of a rate to make it start to feel more like a February rain event, although it's still a lot warmer than normal. Now, having gotten that out of the way, we do have some Chem review to do. Because, as it turns out, the quiz grades were atrocious. Even mine. My 80 on that quiz happened to be my lowest grade of the year, which, while the 80 was very disappointing, something that I would take pride in is the fact that I never got below an 84 for the entire first half of the year. Unfortunately, that ends today, but I've still never gotten sub 80, and that is a streak that I'm hoping to continue by continuing to do well in honors chemistry. But considering that a lot of people got throughout the 75 to 85 territory, this is something that needs an intense review. First of all, the test will be mostly multiple choice. So a lot of the errors that you made that you lost points for on the quiz, on the test, you're going to know what it is because you're going to see. I know one of my errors was for vanadium. I forgot to put it in parentheses, and I forgot to use the stock system. It was, forgot what it was, but I didn't actually, I think it was vanadium 4 sulfate. I also got an ATE to ITE, polyatomic confused. It was a disaster, my quiz. But balancing seems to be easy. But what I especially have to remember on a test is that when I have to balance before doing anything else. So we need to talk about a few things. So first of all, predicting the products. So how do you predict the products? Well, depending on what you're given, you have to look to see whether or not a reaction will happen. And you need to you need to look and see if a reaction will happen, and then figure out whether or not it's single placement, double placement, whether or not it's cationic or anionic. There's a lot of stuff that gets involved. So, first of all, when you're doing predicting the products, for if it's single placement, first you have to check table J. Especially if it's cationic. If it's anionic, that's non-metal replaces non-metal. An element can only replace an element that is further down on that list. For non-metals, it's fluorine, chlorine, bromine, and iodine. So it just simply goes in order. So the halogens with the lower electronegativities can be replaced by the halogens that have higher electronegativities, the ones that have lower boiling points, a smaller atomic radius. But for metals, it's a lot more confusing. Now, if you see a lithium, then you know it can replace anything, and gold cannot replace anything. But aside from that, I mean, you just really gotta check that table. I mean, even hydrogen is on that list, and it's positive only in acids. And when it's bonded to a non-metal, hydrogen will actually be negative. So it can either be -1 or +1, but it's +1 in like acids. You see? So anyway, as far as the the table J goes. So, like, if you see an element that's higher than another element, the lower element cannot replace the higher element. If it does, write no reaction. Don't even try to solve the problem, because you'll waste valuable test time. You'll only get about 38 minutes to do your test. Don't waste time on a reaction that's going to fail in the long run. I remember our teachers, I fell for this trick, and our teacher said, guys, if you're still on this problem at this point, you're taking way too long, because there's no reaction. So that's how the reference table with table J works. But for a double replacement, that you actually have to list out the products first and look for something. You have to look to see if you see, you have to see a gas, water. By the way, gas can be assumed to be anything covalent or a precipitate. So if both of those fail, you have to go look for a precipitate. And in order for a precipitate, you have to check table F for ions that are soluble and insoluble, and you have to also check the exceptions. For instance, carbonate normally doesn't dissolve, but it will dissolve if it's bonded to an alkali metal, because alkali metals always dissolve, no exceptions. That kind of stuff. You also need to know when you're writing a chemical equation before balancing it that hydrogen, nitrogen, oxygen, and any halogen will always be polyatomic. I mean diatonic. They'll always be diatonic. You'll always see two of them. You'll never see just the one of them. By the way, don't be like that person in our chemistry class who thought bromine and iodine are not diatonic because bromine is a liquid and iodine is a solid. They both are still polyatomic. So that's how predicting the products is going to work. Like if you see calcium carbonate and sodium hydroxide, you're going to get something like sodium carbonate and calcium hydroxide. But then again, you need to check the table, make sure that's insoluble, and I don't even know if that's a real reaction. I just gave something for experimental purposes. Okay, and now we have to go from how to get from a word equation to a net ionic equation. That is another exceptionally important topic that must be touched on. So how do we do it? Well, first of all, from the word equations, you have to then figure out what they're even talking about. And with charges, you're probably going to crisscross them or use least common multiple. Something like that. Because they're going to give it to you in word form. You have to figure out what they are first. Then you need to balance the equation. Equal elements must exist on both sides. After this, you need to write the complete ionic equation. Anything that is aqueous, and you must check table F to see if it's aqueous. Anything that is aqueous solution must be broken apart. And anything else must be kept together. When they're broken apart, you must list the AQ next to it. And you also must give the charge. You don't have to put the AQ before this, but after this, you do have to put the AQ for the rest of the equation. After the AQ stuff, where you break them apart, the thing that isn't, you either put a G if it's covalent, an L if it's water, or an S if it's a precipitate. Once you get past that, you then need to look and see what cancels out, what doesn't. This is why they can't all be aqueous, because if the products are all going to be aqueous, then there's simply not going to be a reaction because they are all going to cancel out. So you need something that won't be dissolved in water. But again, you cancel out any spectator ions that exist, and then the real reaction is going to simply be, the Net Ionic Equation is going to simply be what's left over, and it's almost always going to be a form of synthesis. Or I guess it could be decomposition also. And again, anything that's not aqueous does not get broken up and does not get charges either. God, the weather really is just dreary. After it was so nice, so May-like. I mean, now it's only a drizzle, but we do need the rain. Central Park only saw 0.05 inches of rain on the first 15 days of February, which ranks it at number 2 for the driest first half of February. We cannot get our driest February on record. We just can't. But we need precipitation to do that, and hopefully this rain will alleviate at least some of the drought issues that have been going on here. I mean, considering that we never really fully recover from a drought, I mean, look at how yellow that lawn is over there, for example. Like, if you need visual proof, just look at that.